For parallel operation of transformers, it is generally recommended that the impedances of the two transformers be equal. This is because when transformers are paralleled, they share the load current. If their impedances are not equal, a transformer with the lower impedance will carry a disproportionately large share of the current. This unequal current distribution can lead to overheating of the lower impedance transformer and potentially cause damage. In addition to equal impedance, several other conditions must be met for successful parallel operation of transformers. Firstly, the transformers must have the same voltage ratio. The voltage ratio is the ratio of the primary voltage to the secondary voltage. If the voltage ratios are not equal, a circulating current will flow between the transformers. This circulating current does not contribute to the load current but flows within the transformer windings, causing increased losses and potentially leading to overheating and damage. The difference in voltage ratio should typically be no more than 0.5%. Secondly, the transformers must have the same phase angle. The phase angle refers to the angular displacement between the voltage and current waveforms. If the phase angles are not equal, the transformers will not share the load current equally. This unequal load sharing can result in one or more transformers being overloaded while others are underutilized. The phase angle difference is determined by the transformer's vector group. Transformers being parallel should be of the same vector group or a compatible vector group that does not result in circulating currents. Thirdly, the transformers must have the same polarity. Polarity refers to the instantaneous direction of the voltage in the transformer windings. If the polarities are not the same, the transformers will effectively cancel each other out, and no power will be delivered to the load. Connecting transformers with opposite polarities can result in a short circuit and severe damage to the transformers and the connected system. Polarity can be checked using a voltmeter to ensure voltages are additive when connected in parallel. Fourthly, the transformers must be connected in parallel using properly sized cables or busbars. The cables or busbars must be able to carry the combined load current without overheating. It is crucial to select conductors with sufficient ampacity to handle the total current expected from the parallel transformers. The National Electrical Code, or NEC, provides guidelines for determining the appropriate conductor size based on the ampacity and temperature rating. Parallel conductors should also be of the same material, have the same length, and have the same termination methods to ensure equal current sharing. These additional considerations include tap changers. If the transformers have tap changers, they should be set to the same tap position to ensure equal voltage ratios. Furthermore, consider the transformer kVA ratings. While not strictly required to be identical, transformers with significantly different kVA ratings may not share the load optimally. It's generally better to parallel transformers with similar kVA ratings. Also, consider the short circuit impedance. The short circuit impedance of a transformer is the impedance measured at the primary winding when the secondary winding is short-circuited. Matching the short circuit impedance helps to ensure proper load sharing and limits fault currents. The percentage impedance of the transformers should be as close as possible. Review transformer nameplate data. Before paralleling transformers, carefully review the nameplate data of each transformer to verify that they meet the necessary conditions for parallel operation. The nameplate provides critical information such as voltage ratio, kVA rating, impedance, and vector group. Finally, perform commissioning tests. After connecting the transformers in parallel, it is essential to perform commissioning tests to verify that they are operating correctly and sharing the load as expected. These tests may include measuring currents, voltages, and temperatures to ensure that the transformers are within their operating limits. In summary, paralleling transformers requires careful consideration of several factors, including impedance, voltage ratio, phase angle, polarity, and conductor sizing. By ensuring that these conditions are met, you can achieve safe and efficient parallel operation of transformers.